Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. For this problem, we first observe that the recurrence relation an plus 1 equal to nan behaves like the factorial or the gamma function, but we'll still need to figure out what a1 is. Okay, so just for instance, if we set n equal to 7, for instance, we have a8 equal to 7 times a7. For a7, we can actually repeat the same process, but this time n will be equal to 6, so we have 6a6, and we'll continue in this fashion. So we can continue like this all the way until when n is equal to 1. So the ending portion is going to look like 1 times a1. And if you observe, this is just equal to 7 factorial a1. So as a matter of fact, we just start from 7, we have a8, so it's just one step behind. So in particular, we're interested in a2022, which will now be equivalent to 2021 downwards, so that's factorial times a1. So what I actually want now is to sum all the possible numbers of zeros we could have. Okay, so to get a possible number of 0, we have to first of all observe that when we have a number, a positive integer, we can factorize it into different prime factors. Now to figure out the number of zeros, that corresponds with the highest power of 10 we can factor out from n. And 10 breaks down to 2 and 5, so this means we should be interested in the factorization involving the powers of 2 and the powers of 5, and then some other leftovers. So here the GCD of m and 10 should be 1. So 2 doesn't divide m, 5 doesn't divide m. So these are all the highest powers of 2 and 5 we could get. Now once we have this, any pair of 2 and 5 will create 10. So that means the highest power of 10 we can get will correspond to the minimum of alpha and beta, because we can only go as much as the minimum can pair with. Okay, so this means overall we're actually interested in figuring out both the powers of 2 and the powers of 5 we can get. And we have two components here. a1 is positive and is less than or equal to 1000. So there are only a few possibilities for the powers of 2 and the powers of 5 we get from that. But on the other hand, 2021 factorial seems a bit more complicated, so let's handle that first, then we'll come back to the bigger problem. So to figure out the number of the powers of 2 and 5 in 2021 factorial, we can simply just use Legendre's formula, which I will just give an example of how it works now, in case of those that may not be familiar with this particular formula. So for instance, we just consider 32 factorial, and let's for the sake of what we want to do, let's say we look at powers of 5. So we want to find the highest power of 5 we could get. Alright, so let me expand this out now. Okay, so this is the product expansion of 32 factorial. So to get the powers of 5, we need to just simply identify those that contribute factors of 5, which will be the multiples of 5, which I'm highlighting now. So I can just put them out under here. So we'll have 10, 15, 20, 25, 30. Some of these might contribute more powers of 5, but for now we'll just remove a power of 5 from each of them. Once we've done that, we'll see that we'll have 1 here left, 2, 3, divide 4, 5, and then here we have 6. So in fact, these numbers under actually gives us a way of counting the numbers of 5 we've factored out. So in fact, there will be 6 of them, as we can see. So we have 5 raised to power 6 so far. And from what is left, we see that some of them could still possibly be multiples of 5. So we still have more powers of 5, which makes sense because this is 5 squared. So we just repeat the same procedure, because this now looks like when we are dealing with 6 factorial. So once again, we'll highlight all the multiples of 5 and we'll divide, and we figure out how many of them. In this case we just have one, and that'll be it. Okay, so the procedure here is just simply we start with the number of interest, and then how this relates to 6 is just divide by 5, and we ignore the remainder because 30 will be the highest multiple less than that number. Okay, so we just repeat this procedure until we're done, and then once we multiply all this, we see that by laws of indices we just simply add those powers. So the numbers of interest here, 6 and 1, we just simply add them up. So this is for 32, and we are considering 5. In this case we get 5 raised to the power 7. We can repeat the same procedure for any number with any prime. Okay, so we can do that for 2021 in terms of prime 2 and prime 5. Okay, so for prime 2, let's look at alpha. That's for 2021 factorial. Okay, to get alpha, so first of all we start with 2021, then we keep dividing by 2. Okay, so divide this by 2. If we have a remainder, we ignore the remainder, and we'll continue like this. So this is what we get when we divide by 2 repeatedly. So actually what we just do is we add all these numbers to get alpha for 2021 factorial. Then we can do the same to calculate the value of beta in this case. So once again we do 2021, then we divide by 5 this time around. Okay, so this is what we have, and we just add this up. So from the values we're getting here, we see that beta is going to be a lot less than alpha, so it seems like it might be the point of interest. But also remember that we have a1 contributing powers of 2 and powers of 5, but the highest power of 5 we can get is 625, which is not much. That's just 5 raised to the power 4. So even if we add that to beta, it's still going to be definitely less than alpha. So that means 5 is our number of interest. So we want to calculate the values of beta. So so if, remember, A2022 is 2021 factorial times A1. So from this, for the powers of 5 here, we have beta, which is this number here. Okay, so we can just simply add this. This is 3, take over 1, and we get this 503. So that's the value of beta here. Now the value of beta for A1 actually varies. So it could be a non-multiple, like it may not be divisible by 5, like score prime to 5, or it may be 5 raised to the power 4. That's the highest we could get. So here beta could be 0 all the way down to 4, all the way up to 4. Okay. Okay, so and then since we're multiplying, we just add the indices. That means the possible powers of 5, which also correspond to powers of 10, we could get from this would be 503, 504, 505, 506, and 507. So we just need to add all this to get our final answer. Now, of course, we see that these are in arithmetic progression, so we just get 5 times the average. So multiply that, we get 2525, and that means that the correct option is D. Alright, I hope you enjoyed this, so I'll see you in the next one.